Welcome back, guys. As you know, I'm a physics lecturer, ASLAM MULLA, and we have completed so many chapters so far. And today we'll start with a new chapter, that is the ninth one for in your syllabus. That is mechanical properties of solid. See, mechanical properties of solid. ಇಲ್ಲಿ ನಾವು ಏನು ಹೇಳ್ತೀವಿ, why we are going to learn in this chapter, what we are going to learn in this chapter, and why should we study this chapter is main important. Yes, you are studying, ನೀವು ಸ್ಟಡಿ ಮಾಡ್ತೀರಿ, ಎಕ್ಸಾಮ್ ಬರ್ತೀರಿ, ಪಾಸ್ ಆಗ್ತೀರಿ, ಹೌದಾ? ಬಟ್ ಯಾಕೆ ಸ್ಟಡಿ ಮಾಡಲಾಗತ್ತೀವಿ, ಏನು ಸ್ಟಡಿ ಮಾಡಾಕತ್ತೀವಿ ಅನ್ನೋದು ಮಾಹಿತಿ, ಹೌದಾ? Of course, you can pass this subject by reading this one, by hearting or by understanding the concept, by writing in the examination. Yes, definitely will pass. But why we should learn this chapter and what is the importance of this chapter or this concept is the main important thing. Okay. So as name suggests, it is a mechanical property of solids. Why should we study? What do you mean by mechanical properties? What are the solids? Right? If you take an example of suppose here we are studying the particular mechanical properties. Mechanical properties means what? We are studying only some of the mechanical properties here. It is just an introduction to the mechanical properties of the solid, and here we are just learning some of the mechanical properties. Like you are designing some design ಅಂತಂದ್ರೆ ಏನು, ಫಸ್ಟ್ ಡಿಸೈನ್ ಅಂತಂದ್ರೆ ಏನು ತಿಳ್ಕೊಳ್ಳಿ. ನೀವು ಯಾವುದೋ ಒಂದು ಪ್ರಾಡಕ್ಟ್ ಅಥವಾ ಯಾವುದೋ ಒಂದು ನೀವು ಇಕ್ವಿಪ್ಮೆಂಟ್ ಫಾರ್ಮ್ ಮಾಡಬೇಕಾಗಿತ್ತಪ್ಪ ಅಂದ್ರೆ, ಸಪೋಸ್ ಒಂದು ಗಾಡಿ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರ್ ಮಾಡಬೇಕಾಗಿತ್ತ, ಬೈಕ್, ಸಪೋಸ್ ಯು ಆರ್ ಮ್ಯಾನುಫ್ಯಾಕ್ಚರಿಂಗ್ ಅ ಬೈಕ್, or you are just developing or you are just fabricating a table, kurchi fabricate ಮಾಡಕ್ಕೆ ತಿಳ್ಕೊಳ್ಳಿ, chair or table, something. It has particular some limits. If I take a chair, you might have seen in our college some plastic chairs are there. It has certain amount of limit. If a 200 kg person sits on that, definitely it breaks. So that chair bears only up to 150 kgs. What I am telling its limit. I am telling its design. It cannot withstand more than 150. On what basis I am telling? Depends upon its design. It is designed so it can withstand 150 kgs. If you put more than 150 kg, that chair breaks. Similarly, if you take an example of bike, it can withstand 150 or 200 kgs. Two people can sit easily on that bike. But if you sit 3 persons, then definitely its bike's mileage, petrol consumption will be more. Right? Mileage will be less, petrol consumption will be more. On what basis we are telling this? On the basis of design. Design means what? We are designing, we are overviewing the product. Before manufacturing, we are suggesting the manufacturer to design this product up to this limit. So that's what the design is. Right? Now, in this chapter, we are studying the properties which are helpful in the design of machines, or you can say in the design of some equipments. Like if you take this building, there are some pillars are there. Columns are there. See, those pillars can withstand this much amount of load. Yes, that is a design. This column can withstand this much amount of load. That is what the design. See, we are studying some design parameters in this chapter. Like those parameters or those properties are stress, strain, elastic limit. Like this, we are studying in this chapter. Why to study? To know particular metals or particular objects, particular equipments limit. ಒಂದು ಬಾಡಿದು ಒಂದು ಆಬ್ಜೆಕ್ಟ್ದು ಒಂದು ಹೇಳ್ತಾರೆ, ಒಂದು ವಸ್ತುವಿಂದು ಮೆಕ್ಯಾನಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಗೊತ್ತು ಮಾಡ್ಕೋಬೇಕಂತ ಹೇಳಿ ನಾವು ಈ ಚಾಪ್ಟರ್ ಸ್ಟಡಿ ಮಾಡಿ. ಮೆಕ್ಯಾನಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಯಾವ್ಯಾವ ಬರ್ತಾವ್ರಿ? ಸ್ಟ್ರೆಸ್ ಬರ್ತೈತಿ, ಸ್ಟ್ರೇನ್ ಬರ್ತೈತಿ, ಲಿಮಿಟ್ ಬರ್ತೈತಿ, ಹುಕ್ಸ್ ಲಾ ಬರ್ತೈತಿ, ಲೈಕ್ ದಿಸ್, ಫೆಟಿಗ್ ಬರ್ತೈತಿ. ಇವೆಲ್ಲ ನಾವು ಸ್ಟಡಿ ಮಾಡಬೇಕು. ಇವೆಲ್ಲ ಅಂದ್ರೆ ಏನು, ಫೆಟಿಗ್ ಅಂದ್ರೆ ಏನು, ಸ್ಟ್ರೆಸ್ ಅಂದ್ರೆ ಏನು, ಸ್ಟ್ರೇನ್ ಅಂದ್ರೆ ಏನು, we are going to study in this chapter, right? So we are focusing this chapter mainly on stress, strain. Then there are so many kinds of stress. Depends upon the stress. Some properties are there for the material. We are studying that. What is fatigue? We will study here. And what is the elasticity? What is the plasticity? We will study here. And all these are related to the solid, right? So first we should know what do you mean by n solid. First we solid and real water, right? So what do you mean by solid? You are already familiar with the term solid is, right? So what is solid? Solid and real. Can I say this pen is a solid? Can I say this pen is a solid? Yes, of course, because it is solid. Yes, we know solid. Yeah, solid entry. Ghana vastu, ghana entry. Other table totally. The table solid entry. How solid? Here, gas is it. Is that solid? No, that is a gas. If I take a water, that is a solid. No, that is a liquid. Right? So there are three states of a matter: solid state, liquid state, and gas state. Ghana, drava, anila. What do you mean by solid then? How can you define a solid is? You might have studied in your previous classes like SSLC, 9th, 8th or something. You have studied that solid has definite shape and size. If a body or if a material has definite shape and size, then we call it as a solid. Right? So we can say solid has definite shape and size. Or you can say it is a state of matter which has a definite shape and size. Right? Still more, if I want to tell still more elaborate the term, if I take a gas, I can easily move my hand. Yes, I can easily move my hand in the gas. If I take the water, I can insert my hand and easily I can move. But certain friction will be there or certain resistance will be there, but still I can move. If I take the solid, can I move my hand? No, I cannot. Right? I cannot insert my hand in the solid. In solid ಹೌದಾ ಅದೇ ನೀರು ತಗೊಂಡ್ರೆ ಆರಾಮಾಗಿ ಕೈ ಹಾಕ್ಬೋದು, ಕೈ ಹಾಕಿ ಅಳೆಯಾಡ್ಸ್ಬೋದು. ಒಂದು ಸ್ವಲ್ಪ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇರ್ತೈತಿ, ಬಟ್ ನನ್ನ ಫೋರ್ಸನ್ನು ಅಳೆಯಾಡ್ಸ್ಬೋದು. ಅದೇ ಗಾಳಿಯಾಗ ಒಂದು ಸ್ವಲ್ಪ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇರೋದಿಲ್ಲ, ನಾ ಹ್ಯಾಂಗ್ ಬೇಕಾದ್ರೆ ಅಳೆಯಾಡ್ಬೋದು. ಹೌದಾ ತಿಳಿಲಾಗತ್ತೈತಿ. ಸೊ ಹೌ ಕ್ಯಾನ್ ಐ ಡಿಫೈನ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ದಿಸ್? ಹಿಯರ್ molecules are compactly packed, very in the solid, right? But in the gases are very loosely bound, very loosely. Illon molecule, illon molecule, illon molecule. ಹೌದಾ in a solid, the force of attraction between the molecule is very high. ಹೌದಾ ಯಾಕಂದ್ರೆ ಒಳಗೆ ಹೋಗೋದಿಲ್ಲ, ಒಳಗೆ ಹೋಗೋದು ನೋಡಿ ಕೈ ಹೋಗೋದಿಲ್ಲ. ಅದ ಗ್ಯಾಸ್ ಒಳಗೆ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಭಾಳ ವೀಕ್ ಅದ ರೀ, ಬಟ್ ಐತಿ ಭಾಳ ವೀಕ್ ಅದ, ಬಟ್ ಐ ಕ್ಯಾನ್ ಮೂವ್ ಮೈ ಹ್ಯಾಂಡ್ ವೆರಿ ಈಸಿಲಿ. ಅದೇ ಲಿಕ್ವಿಡ್ ಹೋಗ್ತಂದ್ರೆ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ weaker than solid but stronger than air, right? So I can tell that in the solid, molecules are compactly packed comparing with liquids and gases, right? So depends upon the molecular position or compactness, I can define the solid. Are you getting my point? Right. So how can I define the solid? Solid has, it is a state of matter, state of matter has, which has definite shape and size, right? Or you can say also say that in the solid molecules are compactly packed, right? So molecules are compactly packed means where they are very near to each other, their force of attraction is very higher, very much higher compared to liquid and compared to gases, right? So this is really the solid. Solid, you already familiar with the term, so I am not going in detail. Solid, what solid and what is it. Only I have defined and we talked about the compactness of the molecule, right? Now, if I take a solid like this, now can I tell rubber, so rubber eraser, is that a solid, liquid or gas? What it is? Of course it is a solid, right? Take an imagination of that rubber. Take an imagination of that rubber and hold that rubber in your hand. Now just pull it, both the sides, just pull apart. What will happen? Is it extending? Yes, of course it is extending. Or just twist it. Just twist it. Is it twisting? What is happening there? Here, first time when you extend it, when you applied a pull on both the sides, its length changes. ಯಾವಾಗ ನೀವು ಜಗ್ಗಿದ್ರಲ್ಲ ಅದರ ಲೆಂತ್ ಚೇಂಜ್ ಆಯಿತು. ಯಾವಾಗ ಹಿಂಗೆ ತಿರುಗಿಸಿದ್ರಲ್ಲ ಅದು ಟ್ವಿಸ್ಟ್ ಆಯಿತು. ಏನಾಗ್ಲತ್ತರಿ ಇಲ್ಲಿ ಹಿಂಗೆ ಮಾಡಿ ಹಿಗ್ಸಿದ್ರೆ ಅದರ ಲೆಂತ್ ಚೇಂಜ್ ಅಂದ್ರೆ ಏನ್ರಿ ಡೈಮೆನ್ಷನ್ ಚೇಂಜ್ ಆಗ್ಲತ್ತೈತ ಹೌದಾ ಲೆಂತ್ ಇಸ್ ಅ ಡೈಮೆನ್ಷನ್ ಲೆಂತ್ L dimension F yes if you are applying the force its dimension is changing if you are twisting it just rotating it on the both side then its shape is changing this shape is changing ಹಂಗಂದ್ರೆ ಇಲ್ಲಿ ನಾವು ತಂತಾನೆ ಆಗ್ಲತ್ತೇನ್ರಿ ಸ್ವಿಮ್ಮಿಂಗ್ ರಬ್ಬರ್ ಚೇಂಜ್ ಆಗ್ತಾವ ಆಗ್ತೈತೇನ್ರಿ ಹೌದಲ್ಲ ಯಾಕಾಗ್ತದೆ ಹಂಗಂದ್ರೆ ಏನ್ ನೆಸೆಸರಿ ಐತೆ ಅದಕ್ಕೆ if I want to change the shape of the body what should I apply yes it is a force right I'm pulling means what I'm applying the force I'm twisting it means what I'm applying the force so I'm twisting means I'm applying the force then I'm pulling it means I'm applying the force right so due to the application of force what is happening here the change of shape or the size is taking place right so this change in shape or size if it is happening in the solid change in shape ಆಗ್ಲತ್ತೈತಿಪ್ಪ change in size ಆಗ್ಲತ್ತೈತಿಪ್ಪ ಅಂತಂದ್ರೆ ಇದಕ್ಕೆ ಒಂದು ಟರ್ಮ್ ಐತಿ ಅದಕ್ಕೆ ನಾವು ಏನಂತೀವಿ ಒಂದು ಟರ್ಮ್ ಡಿಫಾರ್ಮೇಷನ್ ಅಂತೀವಿ what you call it as deformation deformation ಅಂದ್ರೆ ಏನ್ರಿ change in shape or size of the body now if you take a hammer ತಗೋರಿ ಒಂದು ಕಬ್ಬಿಣದ ರಾಡ್ ತಗೊಂಡು ಹೊಡಿಯೋಣ ಚಪ್ಪಟಾಗ್ತದೆ ಹೌದಾ it just get thin when you hit a rod of metal with a hammer ಚಪ್ಪಟಾಗ್ತದೆ shape change ಆಯ್ತ್ರಿ ಎತ್ತರ ಸಮಸ್ಯೆ ಏನಾಯ್ತು by the application of force so ಏನಾಯ್ತು ಇದು deform ಆಯ್ತು permanent deform ಆಯ್ತು ಹೌದಾ so deformation of a solid means when you apply the force shape either shape can change or the length can change or dimension can change or both can change right so this process where when applied force is there and change in shape size takes place that is called the deformation getting my point what is deformation is because whatever learning now from in this chapter from now we are learning deformation ಹಿಡಿದು ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ ಡಿಫಾರ್ಮೇಷನ್ ಅನ್ನೋದು ಪಕ್ಕಾ ಮಾಡ್ಕೊಂಡಿರ್ಬೋದು ಡಿಫಾರ್ಮೇಷನ್ ಅಂದ್ರೆ ಏನ್ರಿ ಎಸ್ ಚೇಂಜ್ ಇನ್ ಶೇಪ್ ಅಥವಾ ಚೇಂಜ್ ಇನ್ ಸೈಜ್ ಆಗೋದು ನಾವು ಏನಂತೀವಿ ಡಿಫಾರ್ಮೇಷನ್ ಅಂತೀವಿ ರೈಟ್ ಸೊ ಡಿಫಾರ್ಮೇಷನ್ when force is applied on solids comma solid changes its shape or size if shape or size changes then it is called deformation right shape may get changed or what shape may get changed or length or diameter may change so it is what the deformation is right its value may change ನೀವು ಹಿಡಿದು ಒತ್ತಿದ್ದಪ್ಪ ಅಂದ್ರೆ cross section area change ಆಗ್ತದೆ volume change ಆಗ್ತದೆ ಅದಕ್ಕೂ ನಾವು deformation ಅಂತೀವಿ if I just apply the force on it on all the four sides then its cross section area changes right the cross section area changes means of course it is a deformation yes ನಿಮಗೆ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಅಂತ ಗೊತ್ತಿರಬೇಕು ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಅಂದ್ರೆ ಏನ್ರಿ ಇದು ನೀವು ಹಿಂಗೆ ನೋಡಾಕತ್ತೀರಿ ಇಟ್ ಇಸ್ ಅ ಸಿಲಿಂಡ್ರಿಕಲ್ ರೈಟ್ ಇಟ್ ಇಸ್ ಅ ಸಿಲಿಂಡ್ರಿಕಲ್ ಇಲ್ಲಿ ಸರ್ಕಲ್ ಅದ ಲೆಂತ್ ಐತಿ ಮತ್ತು ಇಲ್ಲೊಂದು ಸರ್ಕಲ್ ಅದ of course it is cylindrical if I cut this and observe from this ಎಲ್ಲಿ ಕಟ್ ಮಾಡಿರ್ತಿರಲ್ಲ ಅಲ್ಲಿ ನೀವು ನೋಡಾಕತ್ತೀರಪ್ಪ ಅಂತಂದ್ರೆ whatever the area is visible to me that is what the cross section area right so if I take an example of let me take this duster if I take an example of this duster right it is irregular shape here you may say it is a smaller area and here it is a larger area if I cut here and observe from this side whatever section is weaving that is what the cross section area getting my point cross section area section ಮಾಡೋದು ಅದರ ಏರಿಯಾ right section ಮಾಡೋದು ಅದರ ಏರಿಯಾ section ಹೆಂಗಿರಬೇಕು it should be and perpendicular plane ಹೆಂಗಿರಬೇಕು perpendicular to the object then it is called a cross section area because here whatever we are defining, ಅಲ್ಲಿ ಒಂದು term ಬರ್ತವೆ cross section area ಅಂತ ಹೇಳಿ. So that you should familiar with the cross section area, right? So coming back to the deformation, it is nothing but when force is applied on the solid changes their shape or the size. This is called the deformation. Then here we are particularly forces applied. See, due to this force, body does not changing its state from rest to motion. Right? We have defined force as if the body changes its state of rest to motion, then it is called a force. But here, shape change agala. Hinta force now ಏನಂತೀವಿ? Deformation force. Right? So this kind of force, due to which body is changing its shape and size, such force is called deformation force. Getting my point? The force due to which body, we can say, force which when applied on the body changes its shape or the size or both. Such force is called deformation force. Right? So I'll write here deformation force. Force which when applied on body changes its shape or size. Such force is called deformation force. Deformation force. Now, this is what the deformation force is. Right? So, depends upon the deformation. We are dividing solids into two groups. In deformation, again base maga. Now, solid is divide ಮಾಡ್ತೀವಿ. Like rubber ತಗೋತೀರಿ. ರಬ್ಬರ್ ಏನು ಮಾಡ್ರಿ ನಿಮ್ಮ ತಲೆ ಹಾಕೋತಿಲ್ಲ ರಬ್ಬರ್ ತಗೊಂಡ್ರೆ ಜಗ್ಗಿ ಬಿಡೋಣ ಜಗ್ಗಿ ಬಿಟ್ರೆ ಹಿಂಗೆ ಇಷ್ಟು ಜಗ್ಗಿ ಬಿಟ್ರೆ ಇಲ್ಲೇ ಬರ್ತೈತೆ ಹೊಳೆ ಬರ್ತೈತೆ ರೀ ಹೊಳೆ ಬರ್ತದೆ ಹೌದಾ ಇದೊಂದು ಪ್ರಾಪರ್ಟಿ ಅದ ಚಿಂಗಮ್ ತೊಗೊಂಡು ಚಿಂಗಮ್ ಕಡಿತಿರ್ತೀರಿ ಕಡ್ದು ಹಿಂಗೆ ಮಾಡಿ ಜಗ್ಗುನ ಜಗ್ಗಿ ಬಿಡು ಹೊಳೆ ಬರ್ತೇನೆ ಬರಲ್ಲ ಅಲ್ಲೇ ಬರ್ತದೆ ರೆಡಿ ಮಾಡಿ ಸೊ ಚಿಂಗಮ್ ಈಸ್ ಆಲ್ಸೋ deforming. Rubber is also deforming. When the rubber is left, rubber is getting its original shape and size. It is rebagging or re-getting its original shape and size. But when you leave a chewing gum, when you leave it, it will never come back to its original shape and size, but it falls down. What is the difference? First material is getting deformed. After deformation force is removed, it is getting its original shape and size. But here does not getting original shape and size. The materials which regains, I'll say instead of which regains their original shape and size after removal of deformation force. ಯಾವ ಮಟೀರಿಯಲ್ ಡಿಫಾರ್ಮೇಷನ್ ಫೋರ್ಸ್ ತೆಗೆದು ಕೂಡಲೇ ಅದ್ರ ಒರಿಜಿನಲ್ ಶೇಪ್ ಅಂಡ್ ಸೈಜಿಗೆ ಬರ್ತಾವ ನೋಡ್ರಿ ಅಂಥವು ನಾವು ಇಲಾಸ್ಟಿಕ್ ಮಟೀರಿಯಲ್ ಅಂತೀವಿ ಇಲಾಸ್ಟಿಕ್ ಮಟೀರಿಯಲ್ ಅಂತೀವಿ ಹೌದಾ ಸೊ ಬಾಡೀಸ್ ವಿಚ್ ಡು ನಾಟ್ ರೀಗೇನ್ಸ್ ದೇರ್ ಒರಿಜಿನಲ್ ಶೇಪ್ ಅಂಡ್ ಸೈಜ್ ಸಚ್ ಬಾಡೀಸ್ ಆರ್ ಸಚ್ ಮಟೀರಿಯಲ್ಸ್ ಆರ್ ಕಾಲ್ಡ್ ಪ್ಲಾಸ್ಟಿಕ್. ಯಾವ ಮಟೀರಿಯಲ್ ಚಿಂಗಮ್ ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡು ಚಿಂಗಮ್ ಹಿಂಗೆ ಜಗ್ಗಿ ಬಿಟ್ರೆ ಹೊಳ್ಳಿ ಬರೋದು ಹೊಳ್ಳಿ ಬರಲಾರಂಥ ವಸ್ತು ಈಗ ಹೊಳ್ಳಿ ಏನು ಮಾಡಬೇಕು then does not regain their original shape and size. Anta material name entu plastic material. So elastic material and plastic material we have classified depends upon the deformation. So elastic and plastic materials. So elastic and the plastic materials. First, what do you mean by elastic materials? So, elastic materials are the materials are the materials when deformation force is removed. See, I am holding rubber here and I am stretching it. Imagine I am stretching it. When I leave or when I remove the deformation force, rubber regains its original shape and size. Right? Such material are called the elastic material. Right? So elastic materials are the materials when the force, or you can say deformation force, is removed, they regain their original shape and size. Right? So let me write materials which regain their original shape and size. Original shape and size. After removal of deformation force. Right? So such materials are called elastic materials. Right? Then elastic materials. Now these elastic materials are behaving like this because of the one property, that is elasticity. So elasticity is a property of material. If this elasticity is there in the material, body regains their original shape and size. Right? If elasticity property is not there in the body, they never regains their shape and size. Getting my point? So elastic materials. So elasticity ಅನ್ನೋದು ಒಂದು ಪ್ರಾಪರ್ಟಿ ರೀ. ಆ ಪ್ರಾಪರ್ಟಿ ಇದ್ದಿದ್ದಕ್ಕೆ elastic material ಆಗ್ತಾವು. ಹೌದಾ? ಸೊ elasticity ಹೆಂಗೆ ಡಿಫೈನ್ ಮಾಡ್ತೀರಿ? elasticity ಇದು ಒಂದು ಪ್ರಾಪರ್ಟಿ. ಆ ಪ್ರಾಪರ್ಟಿ ಬಾಡಿ ಒಳಗೆ ಇದ್ರೆ ಆ ಬಾಡಿ regains its original shape and size after the removal of force. So it is a property of the material by the virtue of which body regains its original shape and size after removal of deformation force. Right? Take a screenshot. Then we will define what is the plasticity, what is elasticity, plastic material, then plasticity. So just to take out screenshot, we will go further. Okay, so now let us move with the next term, elasticity. So I told you that elasticity is a property of the material which present in the body, then body regains its original shape and size when the applied force or the deformation force is removed. Right? So let us write the definition. Elasticity, property of material due to virtue of which body regains original shape and size when deformation force is removed. Right? So if the deformation force is removed, body regains its original shape and size due to one property. That property is called elasticity. Right? If the elasticity is present, definitely it regains original shape and size. If you take a wood, example of wood, one cutting ಮೇಲೆ force apply ಮಾಡಿದ್ರೆ ಕೈಯಲ್ಲಿ ಜಗ್ಗುನ ಹೌದಾ ಮುರಿದು ಬರ್ತೈತಿರೋದು. Right? So wood has a particular property. When you apply the certain amount of force, it breaks. Anta material we will study, right? Those are not elastic materials. Those are not elastic materials. Similarly, if you take a chewing-gum, I give an example of chewing-gum. If you drag it and leave, it does not regain elasticity. Elasticity is body button. Rubber elasticity. So I am quoting only two examples to get the clear picture of elasticity and plasticity. Harsh example you may get confused. So I am only taking two examples so that it will be clear concept to you, right? So next, let us go for the next material or next kind of material, that is plastic material. So what do you mean by plastic materials? ಸಣ್ಣ ಡಿಫರೆನ್ಸ್ ಯಾವುದು? ಏನು ಡಿಫರೆನ್ಸ್ ರೀ? ಇಂಥ ಮಟೀರಿಯಲ್ ತನ್ನ ಸ್ಥಿತಿಗೆ ಒಳ್ಳೆ ಬರೋಲ್ಲ ಯಾವಾಗ ಫೋರ್ಸ್ ರಿಮೂವ್ ಮಾಡಿರ್ತಾರೆ. ದೇ ನೆವರ್ ರೀಗೇನ್ ದೇರ್ ಒರಿಜಿನಲ್ ಶೇಪ್ ಅಂಡ್ ಸೈಜ್ ಆಫ್ಟರ್ ರಿಮೂವಲ್ ಆಫ್ ಡಿಫಾರ್ಮೇಷನ್ ಫೋರ್ಸ್. Such material are called plastic material, right? So plastic materials are the materials which do not regain or does not regain their original shape and size after removal of deformation force. ಭಾಳ ಸಣ್ಣ ಡಿಫರೆನ್ಸ್ ಇದೆ. ಅಲ್ಲಿ ಏನಾಗ್ತದೆ, ಪ್ಲಾಸ್ಟಿಕ್ ಇಲಾಸ್ಟಿಸಿಟಿ ಒಳಗೆ ರೀಗೇನ್ ಆಗ್ತದೆ, ಇಲ್ಲಿ ಆಗೋದಿಲ್ಲ ಆಫ್ಟರ್ ರಿಮೂವಲ್ ಆಫ್ ಡಿಫಾರ್ಮೇಷನ್, ರೈಟ್? Let me write the definition, very simple. Materials which does not regain their original shape and size after removal of deformation force are called plastic materials. Example: chewing gum, then you can say plastic pen, plastic chair. Then there are so many examples you can take. Paper, whatever called, those are the plastic materials, right? Now, regarding this, we have written certain elasticity. However, plasticity no one right? So plasticity, it is a property of the material due to virtue of which plasticity ಈ ಪ್ರಾಪರ್ಟಿ ಇದ್ದಿದ್ದಕ್ಕೆ ಬಾಡಿ ಹೊಳ್ಳಿ ಅದರ ಒರಿಜಿನಲ್ ಶೇಪ್ ಆ್ಯಂಡ್ ಸೈಜಿಗೆ ಬರೋದಿಲ್ಲ, ರೈಟ್? ಇಂಥ ಪ್ರಾಪರ್ಟಿ ನಾವು ಏನಂತೀವಿ? ಪ್ಲಾಸ್ಟಿಸಿಟಿ ಅಂತೀವಿ. ಸೊ ಪ್ಲಾಸ್ಟಿಸಿಟಿ, ಇಫ್ ಐ ರೈಟ್ ಪ್ಲಾಸ್ಟಿಸಿಟಿ, it is a property of material. Yes, property of material due to virtue of which body ಇಲ್ಲಿ regains ಇಲ್ಲಿ never regains their original shape and size after removal of the deformation force. So ಇಲ್ಲಿ ಏನು regains ಐತೆ ನೋಡಿ, ಇಲ್ಲಿ ಬರೀ never regains ಅಥವಾ does not regains ಆಗ್ತದೆ, right? So property of the material, I write property of the material due to which body or material does not regain its original shape and size this property is called a property of the size. E is called plasticity. Definition of size, right? So it is what the plasticity. Due to the virtue of which plasticity material within the curve, body does not regain its original shape and size, right? So it is called the what plasticity. Now, if we talk about now we have spoke about elasticity and plasticity. See, there are some material like quartz material. When you apply the force, it gets stretched. It gets stretched or it deforms. When you remove the force, immediately they regain their original shape and size. Right? Without one ಸ್ವಲ್ಪ deform ಆಗುವುದು. Like when you remove the force, they never get deformed. But if you take an example of rubber or something, if you extend it and leave it, it takes time. First it regains almost, then it takes time to reach its original shape. ಜಗ್ತಿರಿ ರಬ್ಬರ್ ಜಗ್ತಿರಿ ಬಿಡ್ತೀರಿ ಇಲ್ಲಿ ಮಟ್ಟ ಆಗ್ತೈತ್ರಿ ಆಮೇಲೆ ಏನಾಗ್ತದೆ ಸೌಕಾಸಾಗಿ ಬರ್ತೈತಿ ಅನ್ಸ್ಟಿಟ್. ಇಫ್ ಯು ಅಬ್ಸರ್ವ್ ನೀವು ನೋಡಿರಬೇಕು ಇಟ್ ಟೇಕ್ಸ್ ಟೈಮ್ ಟು ರಿಗೇನ್ ಇಟ್ಸ್ shape and size. Such materials are not perfect plastic materials. Sorry, perfect elastic materials. Right? So materials which regains their original shape and size within no time. Within no time. ನೀವು external force remove ಮಾಡಿದ್ರೆ within no time, if they regain their original shape and size, such material are called perfect elastic materials. Perfect elastic materials, right? So perfect elastic materials are the materials which regains original shape and size immediately after the removal of load or after the removal of deformation force. So you should know what do you mean by the perfect elastic material. Perfect elastic materials so these are the material which regains immediately regain original shape and size immediately after removal of deformation force. Example for this: quartz material, quartz crystalline material, or the example for D20, right? So this is what the plastic perfect elastic material. Perfect elastic means if you remove the load, if you remove the external deformation force, or deformation force, within no time, body regains their original shape and size. Suddenly, they regain original shape and size. If you take an example of rubber, if you stretch it and leave, it takes time to come to certain length, then it slows down. Right? Such material are not perfectly elastic. Perfectly elastic means when you remove the load, they suddenly regain their original shape and size. Right? Such material are called the perfect elastic material. So hope you just take down screenshot of this so that I can move further. Okay, so now let us talk about the perfect plastic materials. Perfect plastic materials. See, if I take an example of plastic chair or plastic pen, if I apply the force, bit larger force, when I remove the force suddenly, bit of the length it goes, like it regains bit of the shape and size. And it regains amount of the shape and size regain ಮಾಡ್ಕೋತೈತೆ. ಹೌದಾ? ಯಾವ್ದು ಬೇಕಾದ ಮಟೀರಿಯಲ್ ತೊಗೊರಿ, ಯಾವ್ದು ಬೇಕಾದ ಪ್ಲಾಸ್ಟಿಕ್ ಮಟೀರಿಯಲ್ ತೊಗೊರಿ, ಅಂಥವು ಮಟೀರಿಯಲ್ ಒಂದು ಸ್ವಲ್ಪ ರೀಗೇನ್ ಮಾಡ್ಕೋತಾರೆ, ಏನು ಶೇಪ್ ಆ್ಯಂಡ್ ಸೈಜ್. ಹೌದಾ? ಅಂಥವು ಮಟೀರಿಯಲ್ ಪರ್ಫೆಕ್ಟ್ ಪ್ಲಾಸ್ಟಿಕ್ ಅಲ್ಲ. ಪರ್ಫೆಕ್ಟ್ ಪ್ಲಾಸ್ಟಿಕ್ ಮಟೀರಿಯಲ್ಸ್ ಆರ್ ದ ಮಟೀರಿಯಲ್ಸ್ ವಿಚ್ ನೆವರ್ ಗೇನ್ಸ್, ವಿಚ್ ಡಸ್ ನಾಟ್ ಗೇನ್ ದೇರ್ ಒರಿಜಿನಲ್ ಶೇಪ್ ಆ್ಯಂಡ್ ಸೈಜ್ even by a small amount. ಸ್ವಲ್ಪನೂ ಚೇಂಜ್ ಮಾಡಲಾರದು. if I twist a rubber, then rubber will be that position itself. ಬಟ್ ಸ್ವಲ್ಪ ಚೇಂಜ್ ಆಗೋದು. ಅಂಥ ಮಟೀರಿಯಲ್ಗೆ ನಾವು ಪರ್ಫೆಕ್ಟ್ ಪ್ಲಾಸ್ಟಿಕ್. ಹೌದಾ? ಒಂದು ಯಾವುದು ಬೇಕಂದ್ರೆ ನೀವು ನೇಚರ್ ಯಾವ್ದು ಬೇಕಾದ ಮಟೀರಿಯಲ್ ತಗೋರಿ, ಇಟ್ ಮೇ ಬಿ ಪ್ಲಾಸ್ಟಿಕ್, ಇಟ್ ಮೇ ಬಿ ಇಲಾಸ್ಟಿಕ್. ನೋ ಮಟೀರಿಯಲ್ಸ್ ಆರ್ ಪರ್ಫೆಕ್ಟ್ ಪ್ಲಾಸ್ಟಿಕ್ ಆರ್ ಪರ್ಫೆಕ್ಟ್ ಇಲಾಸ್ಟಿಕ್. ನೆನಪಿಟ್ಬಿಟ್ಟು, no materials are perfect plastic or perfect elastic. For our sake of convenience or for our sake of study, we are taking some assumption like this material is a perfect plastic or this material is perfect elastic. But in the nature, no such perfect plastic or perfect elastic materials are available. So perfect plastic material are the materials which never regains original shape and size even by a small amount after removal of deformation force, right? Deformation force. So for example of this, you can say a clay, a good example. Clay materials or clay pots or something. Good example for the material perfect plastic like clay pots or something made up of clay, or you can say putty material. Those are nothing but the example of perfect plastic material, right? So today's class is regarding this much. Like in the today's class we have studied what is the deformation force and two important properties of the material. Those are elasticity and plasticity, and the term related to elasticity and plasticity we have studied. In the forthcoming classes we will study, we will enter into we will study why body behaves elastic, why body behaves like an elastic material, or why it does not behave like a plastic material. Then related terms like we will study what is stress, strain and all. So up to that, just go through the notes given by the college and read those things and make a note of what I taught today, right? So I'll stop and we'll do it in the next class, and thank you.